Allacademy. Always with you.
Hello my dear students, welcome to this online video session on basic thermodynamics. So in the previous session we have discussed the complete theory concepts of work and heat as well as the first law of thermodynamics. And in this session we're going to solve the numericals on the whatever the theory concepts we have discussed in the module 2. So without wasting much time, let us begin with some of the very important numericals, and similar kind of numericals will going to be asked in your examination. So let us start with the first numerical. And the first question is, a system receives 200 kilojoules of heat at a constant volume and rejects 220 kilojoules of heat at constant pressure, during which 40 kilojoules of work is done on the system. The system is brought back to its original state by adiabatic process. Calculate the adiabatic work. If the initial internal energy is 240 kilojoules, then calculate the volume of an internal, so the value of internal energy at all state. Now in this question, and this question is for 10 marks. Okay, this question, these kind of questions will be asked for 8 to 10 marks. Okay, now here, so what he has asked, so he has given a one system which is working in a three different process. One is a constant volume process, another one is a constant pressure process, and the last process is an adiabatic process. Now before we solve these numericals, so we must draw the PV diagram for this particular system. Okay, so based on the given the data, so we should able to draw the PV diagram. And even this PV diagram carries some quantity of marks. Either it may be a 1 marks or 2 marks will be given for this PV diagram. Now what he says, a system receives the heat, means the 250 kilojoules of heat at constant volume, means this is a first process. Then the next process is constant pressure process, this is second process, and the third one is an adiabatic process. So now this is the initial point. Now here to here 1 to 2 means this is a constant volume process, 1 to 2, then constant pressure process. Okay, this is 3, then it is brought back to its initial state using a adiabatic process. Now this is a PV diagram for this particular problem statement. Now here V is a constant and here pressure is constant, and this is a adiabatic process. Understood? Now let us note down all the given datas. Okay, let us write the given datas in the problem statements. As he said 200 kilojoules of heat. Okay, so Q1 to 2 is given. Q1 to 2 is 200 kilojoules. Now similarly, and rejects, so rejects means it is heat is given out, so that is a second process, that is Q2 to 3, that will be minus 220 kilojoules at constant pressure, during which 40 kilojoules of work is done on the system. Work is done on the system means it is also a negative quantity, so work 2 to 3 is minus 40 kilojoules. Now the system is brought back to its original state by adiabatic process. Calculate the adiabatic work if the initial internal energy he has given. So what is the initial internal energy? It is denoted by U. Initial means U1 is given how much? 240 kilojoules. Understood? Now let us calculate the different works, and finally what we need to calculate? We need to calculate adiabatic work. So as it is clearly mentioned, calculate the adiabatic work. Okay, then we need to calculate the value of internal energy at all the states. So this is all about the given datas, and we need to calculate the what is the adiabatic work as well as internal energy at all the state. Now for this one, so let us start with a process 1 to 2, that is process 1 to 2. What is the process 1 to 2? It is a constant volume process, and we all know that during the constant volume process work done will be 0, and as it is mentioned already, it is given, so Q1 to 2 is 200 kilojoules. Now we know that from the first law of thermodynamics, we know that is Q1 to 2 will be equals to U2 minus U1 plus work done. Means the amount of heat added or rejected will be equals to sum of internal energy plus the quantity of work done on the system or by the system, or work transfer. Internal energy plus work transfer will gives us the amount of heat transfer. Now in this condition, so we already know that. So here, so I'll just write it here. Now the work done is 0 as it is a constant volume process. Now Q1 to 2 is given, that is 200 kilojoules. U2 is not given, that we need to identify, but U1 is already known, that is 240 kilojoules. Now if you replace it, so you will get U2, that is internal energy at state condition 2 is, that is around, if I shift it here, this becomes positive, so it is a 440 kilojoules. Now this is a internal energy of at condition 2. This is a U2, that is U2 at state 2, internal energy is 440 kilojoules. Now we have identified one internal energy. Similarly, we need to identify U3, that is at internal energy at third condition. For that one, now we have, to identify that, so we have to move to the process 2 to 3. So this is, one second, I will draw it. 1 2 2 3 P and V. Now process 2 to 3 is what? It is a constant pressure process. The constant pressure process, from the PV diagram as well as from the statement, you can easily get it, that it is a constant pressure process. Now we know that, so already in constant pressure process there will be some quantity of work, but from the first law of thermodynamics we know that Q2 to 3 will be equals to U3 minus U2 plus W2 to 3. Now Q2 is already given, that is amount of, then the constant pressure process sentence, it is clearly given that the 220 kilojoules of heat is rejected. So I have to consider this as a minus 220 kilojoules. Now U3 is unknown, but U2 we have already identified, that is a 440 kilojoules plus, and work is also given. So what is that work? It is said that a 40 kilojoules of work is done on the system at a constant pressure process, done on the system. So I have to consider it as a minus 40 kilojoules. Now if I just replace it, that is U3 will be equals to, so I have to reshift it here. So U3 will be equals to, this becomes plus 440 plus 40 minus 220. So U3 will be equals to, that is internal energy at third condition, it will be, that is 260 kilojoules, because here this becomes a 480 minus 240, it is nothing but 260. Now this is a U3 value, that is internal energy at 3. So now we have identified two internal unknown energies. What is that one? So U1 is already given in the problem statement, that is 240 kilojoules. Now what we have identified? The identified U2, that is U2 at the internal energy at condition 2 is how much? That is 440 kilojoules. These are the unknown which we have identified. Now U3, that is internal energy at condition 3 is 260 kilojoules. Now if you do this, if you identify these three, so here you will get 2 marks, and for this one you will get 2 marks, and for this one you will get 2 marks. So total how much? 6 marks already allotted, and 2 marks or 1 marks for this one. Now still the problem is not completed. So it is given that we need to identify adiabatic work done, that is the whatever the process is there from 3 to 1, that is the adiabatic process. In that condition, what is the work transfer that we need to identify? Now let us move to the next one, that is process 3 to 1, which is a adiabatic process. Now in adiabatic process, we already know that the quantity of heat transfer will be 0. Now from the first law of thermodynamics, that is Q3 to 1 will be equals to U1 minus U3 plus W3 to 1. W3 to 1. Now in adiabatic process, the heat transfer will be 0. So I'll just rewrite it here. If I interchange these one, this becomes minus U1 minus U3 will be equals to W3 to 1. Okay, already we have U1 value, U2 value, U3 value. So just substitute that one. So I will just substitute U1 minus what is a U1? It is a 240 minus what is a U3? It is a 260. So that will be equals to W3 to 1. So if you substitute it, if you simplify this one, so this becomes minus and this becomes plus. So if you multiply minus inside, so it becomes the plus 260 and this becomes minus. So the total, the work done in adiabatic process will be equals to 20 kilojoules. Now this completes the complete problem. So this steps completes the complete problem, and here you will get a 2 marks. So total 10 marks. This is how it will be distributed. So 2 marks for identifying internal energy for 2 and 3. Then the next step, 3 marks or 2 marks will be allotted for the identifying of adiabatic work. So this is the similar kind of problems will be asked in your examination. This is how you need to solve the numericals. And as I said, so the PV diagram plays very important role while solving the numericals, and even this carries the marks in your for your marks. So total whatever 8 or 10 marks will be there, in that one some quantity of 2 marks or 1 marks will be allotted for this PV diagram also. So let us move to the next problem statement. So the next problem statement is in a non-flow process, the pressure and the volume are related by P is equals to V square plus 20 by V, where P is in pressure, that is in bars, and V is in a volume, that is a meter cube. During process, the volume changes from 2 meter cube to 6 meter cube, and the heat added is 9000 kilojoules. Determine the change in internal energy. Now in this question, so what process we need to take, that is the first thing. So here it is clearly mentioned that there is a change in the volume. So this should not be a constant volume process, and there is no mention of whether it is an adiabatic process or polytropic process. So let us take this as a constant pressure process. Okay, now this is a constant pressure process. Okay, 1 to 2. Now let us note down the given values, given data in this one. So what are the given value? The P is given in the relation of V, that is V square plus 20 by V. Okay. Now what is the change in the volume? That is it changes from 2 meter cube to, that is V to 6 meter cube. Then what is the amount of heat added? That is 9000 kilojoules. It is added as a 9000 kilojoules. Okay. Now we know that the work done in a constant pressure process is identified by using integration of P into dV from 1 to 2. What is a 1 to 2? That is a change in the volume. So that is a 2 meter cube to 6 meter cube. Now let us substitute this P value, that is a V1 to V2. What is the P value? It is given in the form of relation, that is V square plus 20 into V into dV. If I integrate this one, I will get it that V2 square, V2 cube, V1 cube divided by 3 plus, okay, that is what is the next one, 20 ln V2 by V1 into 10 raised to 5. Now why I have taken this 10 raised to 5? Because it is clearly given that P is a pressure which is in the bars. Here it is clearly mentioned, so I have to multiply it with the 10 raised to 5 value. Now let us substitute all the given values. What is the given value? V3 is given 6 cube minus 2 cube divided by 3 plus 20 ln 6 by 2. So if you simplify this one, 10 raised to 5. If you simplify this one, you will get, that is a work done as 9 9130 kilojoules. So you'll get 913 kilojoules. 9130 kilojoules of work is done during this process. Now this is not a complete problem. So first we have identified the work done, but what we have asked to identify? So we have asked to identify the change in the internal energy. Now to identify the change in the internal energy, from the first law of thermodynamics we know that Q is equals to delta U plus amount of work done. Now already in the problem statement Q is given, that is 9000 kilojoules is heat is added. Now plus the change in internal energy, it is nothing but U2 minus U1, okay, plus work done we have identified, that is 9130 kilojoules. If I just shift it these terms, so I will get U2 minus U1, or it can be considered as a delta U. So it is a 9000 minus 9130. So the change in the internal energy, it is in the negative quantity, that is minus 130 kilojoules. Now this question is asked for 6 marks. So here the 3 marks is given for to identify the change in internal energy. 2 marks is given to identify this work done 2 marks, and 1 marks is given for the PV diagram. So what is the PV diagram for this one? It is a constant pressure process, PV diagram. So this is a constant pressure process problem. And the next problem statement is, during the constant pressure process in a closed system with the P is equals to 105 kilopascal, and the properties of the system changes from V1, that is 0.25 meter cube, to T1 10 degrees Celsius to V2, that is a 0.45 meter cube, and a temperature of 240 degree Celsius. The specific heat at constant pressure of a system is given by, that is Cp is given in the relation, that is Cp is equals to 0.4 plus 18 divided by T plus 40 kilojoules per kg. Assuming the mass of a system as in a 1 kilojoule kg, determine the heat transfer, work transfer, change in the internal energy, and change in the enthalpy. Now this question is asked for 10 marks, as it is having some more unknowns to identify. That is, we need to identify heat transfer, we need to identify work transfer, we need to identify change in the internal energy, as well as we need to identify the change in the enthalpy. Now this question is a bit lengthier, but very simple. So already we have solved the same formulas has to be used in this one. So first let us list out all the given datas. Okay, so let us list out all the given datas. What are the given datas in this problem statements? Note down. Coming from the first one, the constant pressure process. So he says that it is a constant pressure process. So that is P is equals to 105 kilopascal. Okay. The next V1 is given. V1 is equals to 0.25 meter cube. V2 is given, that is 0.45 meter cube. Whereas T1 is given 10 degrees Celsius. T2 is given how much? It is a 240 degrees Celsius. Cp is given, that is Cp in the form of relation 0.4 plus 18 by T plus 40. So these are the given volume. And mass is given, that is 1 kg. Now these all are the given datas, and in this one we need to identify heat transfer, work transfer, change in the internal energy, as well as change in the enthalpy. Let us start with the first thing. So as it is clearly mentioned, it is a constant pressure process. Now the work done can be easily identified, that is integration of P into dV. Okay, what is a PV into dV? It is P into V2 minus V1. So I can write it easily, 105 into, what is the volume? V2 is 0.45 minus 0.25. So you will get work done, that is work done will be 21 kilojoules. Very simple, so you can easily solve it. Now what is the heat transfer? Q is equals to mCp into delta T. It is a heat, that is a generalized form, but here there are two temperature, that is a mCp into delta T. but this Cp is not given directly. It is given in the form of some equation. So I have to integrate this one 1 to 2 now. So I will write it integration from T1 to T2, that is m. Cp is in the form of equation, that is temperature equation, 4 plus 18 divided by T plus 40 into dt. Okay, into dt. Let us simplify this, or let us integrate this one. Now what is that equation? Q equals to integration of m T1 to T2 0.4 plus 18 divided by T plus 40 into dt. So this was an integration. So that let us integrate this one. Let us take m outside. Now it is a 0.4, that is it is T2 minus T1 plus. Now let us take 18 outside. 18 and it is a ln T2 plus 40 divided by T1 plus 40, T1 to T2. Okay, let us substitute all the values. T1 is given, T2 is given. If you substitute all the values, mass is 1 kg, that is 0.4, then T1 is 240 and T2 is 240, T1 is 40 degrees Celsius, plus 18 ln, then T2 is 240 plus 40 divided by 40 plus 40. So if I simplify this whole equation, I will get heat transfer, that is heat, it is 123 kilojoules. Okay, so if you simplify this term, you will get 123 kilojoules. You may have a question, sir, directly we can take mCp into delta T. So here T is Cp, it is given in the form of some equation, so that has to be simplified. That is why we have went for an integration. Okay, if it is directly Cp value is given, like some 3.14 or some 1.2, directly Cp value is given, directly we can identify Q is equals to mCp into delta T. Already, as we already having a T1 and T2 temperature, but why we have went for integration is that this Cp value, it is given in the form of some T relation. So that's why I have to go for this method, this integration method I have to go for. Now we have identified the work done. Now we have identified the amount of heat transfer. Now what we need to identify? We need to identify change in the internal energy as well as the change in the enthalpy. Now to identify the change in internal energy, that is change in internal energy is equals to, it is nothing but heat minus work. Okay, so that is what is the heat? 123 kilojoules minus 21.2 kilojoules. So if you simplify this one, how much you will get it? You will get 101.8 kilojoules, 1008.8 kilojoules. That is a change in the internal energy. Now what is the change in the enthalpy? Now change in enthalpy, it is nothing but amount of heat transfer. It is equals to amount of heat transfer. Okay, the change in enthalpy is equals to amount of heat transfer. What is the amount of heat transfer that we have identified? That is Q, that is 123 kilojoules. That is the delta H value. Okay, so now here are the final answers. Now in this question, how the marks will be distributed? So to identify the work done, the 2 marks will be given. To identify Q, 2 marks will be given, and to identify this change in the internal, 2 marks will be given, and for this one 2 marks will be given. If it is 8 marks, 2 marks will be given, and if it is for 10 marks, here plus 1, here plus 1. This is how the marks will be distributed in your examination. Hope you understood this question. Let us move to the next one more numerical. A fluid system undergoes a non-flow frictionless process following the pressure volume relation, that is P is equals to 5 by V plus 1.5, where P is in a bar and V is in a meter cube. During the process, the volume changes from, that is 0.15 meter cube to 0.05 meter cube, and the system rejects 45 kilojoules of heat. Determine change in the internal energy as well as change in the enthalpy. Now this kind of problem we have already solved in previous one, similar problem we have solved. Let us solve this one. So in that case there was no change in internal energy as well as change in the enthalpy was not us. In this problem we need to identify change in the internal energy as well as change in the enthalpy we need to identify. Now before that, so let us note down the given data, and this question will be asked for 8 to 10 marks. Okay, 8 to 10 marks. So let us note down the given data. So first P is given in the relation, that is 5 by V plus 1.5. Volume is given, that is V1 is equals to 0.15, and V2 is given, that is 0.05, and the heat is given, that is heat is rejected, so it is a minus 45 kilojoules. So these are the given data. Now we already know that, so it is given that pressure, volume, frictionless, pressure, volume. So which type of work I have to consider? I have to consider it as a constant pressure process, because the volume is changing. The volume is changing. So the work done can be identified integration of 1 to 2 P into dV. Now that is P equals to P is so P is given in the form of some relation. So W is equals to integration of 5 by V plus 1.5. Okay, 1.5 into dV. Now if I integrate this one, I will get it 5 ln V2 by V1 plus 1.5 V2 minus V1. So let us substitute these values, that is 0.15 and the 0.05. So if I simplify this one, if I substitute this V1 and V2 value in this one, I will get work 1 to 2 as around minus 5.643 10 raised to 5. Okay. Now this is a work done during this process. Now once if I identify the work done, now I can identify easily the change in the internal energy. So how this change in the internal energy is identified? From the first law, that is U is equals to delta U plus amount of work done. That is nothing but Q equals to U2 minus U1 plus amount of work 1 to 2. So already it is given that how much quantity of heat is rejected. Q is given, that is minus 45. Heat is rejected. It is clearly mentioned. Now we need to identify U2 minus U1, that is a change in internal energy, plus what is the work done. So work done we have identified, that is a minus 5.643 into 10 raised to 5. It is a 10 raised to 5 and this is 10 raised to 3. It is in kilojoules. It is in kilojoules. So now U2 minus U1 will be equals to minus 5. So it will be U2 minus U1 will be equals to, it is a minus 45 into 10 raised to 3. So if I shift this here, so this becomes plus 5.643 into 10 raised to 5. Yes or no? So now what is the equation? So what is this equation becomes? So this will be U2 minus U1 will be equals to plus, sorry, it is a 519.33 kilojoules. This is a change in the internal energy. Change in the internal energy. Now what is the pressure? What is the pressure? P1 and P2, that we can easily identify from the given equation. That is a relation is given 5 by V1, that is 0.15 plus 1.5. Another one is a P2 is 5 divided by 0.05 plus 1.5. So P1 will be equals to 34.8. P2 will be equals to 101.5 bar. Okay. Now these are the pressures. Now we know that the P2 minus P1, that is work done, can be also identified by using a P1 and P2. Now but the enthalpy relation, but we know that the enthalpy relation, that is given by H2 minus H1 will be equals to U2 plus P2 V2 minus, okay, enthalpy relation plus U1 P1 V1. So this is a enthalpy relation. Just rearrange this equation. Will be equals to U2 minus U1 plus P2 V2 minus P1 V1. Yes. So we have already identified this one. P1, V1 value, we know that. If you substitute all this one, we have identified H2 minus H1 will be equal. So this value we have already identified. We know the pressure value. We know the volume, that is initial volume and final volume. Similarly, P1 and V2 already identified. If you substitute that one, you will get an actual change in the enthalpy. So let us comment what is the actual enthalpy you will going to get in this problem. So you calculate it and comment it in the comment box. Okay, my dear students, hope in this session we have solved some of the different numericals on the first law of thermodynamics. Hope you have clear with all the steps that we have solved. And still, if you are finding any difficulty in understanding these numericals, please go through the video once again. And if you are having any further, if you want any clarification, you can comment it in the comment box and I will try to clarify your all the doubts. And also, dear students, you can find the numericals PDF, which is already available in our website, that is allacademy.blogspot.com. And you can also follow us on a LinkedIn as well as Facebook. Even sometimes we will be posting some of the links so that you can download it very easily on these platforms. So you can also follow us on LinkedIn, Facebook as well as Instagram. So in the next session, again we'll solve the some of the numericals which are related to first law of thermodynamics, which is applied for open system, because in examination these questions are also repeatedly asked. So till that, watch our channel and share the video to your friends.
Click on subscribe button and press the bell icon to get updates from Allacademy.